Welcome everyone to the learning session organized by Mindbowser on game testing. First of all, why don't we start with a quick round of introduction of mine, followed by Aditya, who is my co-presenter for this session. Well, talking about myself, my name is Purushottam, and I have more than 4 years of experience in testing software as well as in games as well, using manual and automation approach. And from the last 1.5 year, I have been collaborated with Mindbowser and working as a QA, managing team of few members. The journey has been amazing so far, and like if you guys want to switch your career or looking for a new opportunity, I will just request all of you to just check out the company's career page for the relevant openings, apply it, and we will get back to you for sure if you meet our expected criteria. So now I would like to call Aditya to introduce him. Over to you, Aditya.
Yes, thank you so much, Purushottam. Hi, everyone. My name is Aditya, and a warm welcome to all of you on this Saturday. I have a total experience of 3 years in testing, and I am working in Mindbowser since 7 months, and it has been a great experience till now. And today we'll be covering the topic of game testing in detail. That's it from my side, Purushottam. You can take over.
Yeah. Thank you, Aditya, for introducing yourself. Okay, guys. So this session is divided into two parts, I would say. In the first, I will walk you through the few of the topics from the presentation and give you in detail idea about testing and introduce you the concept that is game testing, like exactly what exactly you do while testing a game, what makes game testing unique from software testing, and many more. And in the second part, where Aditya will walk you through the core concepts of a game testing, different testing types in games, and what exactly you need to test in each testing type. And then you will get the full understanding of this topic. And in between, if anyone has any questions or concerns, please feel free to ask through a Q&A box in the chat box. And we will try our best to answer all of your questions at the end of your session. Okay, so first thing first, let's just understand the topics of today's session. We will begin with the basic understanding about testing and the different types of testers, then few do's and don'ts in the testing. What are the skills we should have as a game tester? Then different types of boxes or layers present in the game testing. Then we will see the major differences between game and software testing along with the similarities. After that, we will explain different types of game testing, followed by tools that we use in assessing the quality of game. And then finally, we will have our question and answer round. So we will begin with the quick intro or highlights about this presentation. So this presentation will definitely help you to understand the core concepts about game testing and to get the clear thoughts on the rumors that we guys might have heard about game testing. Like, game testing is really easy and anyone can perform it with very ease. If you are not good at coding or, if you are not good at communicating with people, then choose game testing as your career and many more such rumors. So this presentation will give you an overview, introduction to testing in general and how game testing adds additional complexity to the testing equation. So we will start with a quick revision about testing, where we will see what is testing and different types of tester. I know many of us are already familiar with testing. However, revising few basics about testing helps you to understand today's topics with this. So what is testing? So testing is a systematic way of analyzing or assessing the quality of software or game by manipulating test data, and the person who does this is known as a tester. Now let's just understand different types of testers. We have so many categories of testers as mentioned here. but only few of them are glorified and rewarded, like automation tester, functional or non-functional tester, manual tester, like this. So let's just understand other categories as well. So the very first category is administrative tester. So what exactly this kind of a tester does? So this tester focuses on the bigger picture of testing, where they will be, responsible for maintaining the documentation, like spreadsheet, Excel sheets, if you guys have any in the project related, or that might be testing related as in the test plan, test cases document, test scenarios document, etc. So that is the main responsibility of this administrative tester. It administrative again has a high level and a low level administrative tester, but at the end, they are mainly focusing on the bigger picture of testing. Then we have the technical tester. So technical tester builds tool, uses tools, and in general thinks in terms of code. They are great as advocates for testability because they speak the language of the developers. Or in general terms, we these people can call it as SDETs. SDETs are the technical testers, or we can also call them as a subset of automation testers. Okay. So the next category that we have here is analytical tester. So the analytical testers loves models and typically enjoys calculation. Like analytical testers create diagrams, matrices, and outlines. They read long specifications. In other words, we can say analytical testers are those who keep focus on finding optimal path or route that can be used in the application testing. The next category is UAT tester. So UAT tester means the person who tests the software by putting themselves in the shoes of an end user, and they mainly focuses on verifying the end user requirements, whether they are fulfilled or not. And moving onwards, we have manual or automation tester. So it is the most commonly known tester category. This tester are actual person who test the entire software through the different layers like the unit, integration, system, using manual or automation approach. So the person who uses the manual approach is called as the manual tester, and the person who uses the automation approach called it as the automation tester. Then we have functional or non-functional tester. Again, the most popular category of tester who test the functional or non-functional aspects of the software. Then we have embedded tester. Actually, embedded tester is someone who tests both functional as well as non-functional aspects of software. However, embedded tester also checks the synchronization between the software and the hardware part of the system. Like if you go to any mall, so there you have a billing software where there is a barcode reader through which the person scans the barcode, and the system will automatically detect this price. So testing of this embedded system is what we called as the embedded tester. Then finally, we have the system tester, means a tester who is responsible to check each and every detail of a software from scratch, which includes functional and non-functional aspects as well. That we call it as a system tester. And apart from this, uh, as our today's topic is game testing, so obviously the person who tests or verifies the game, we call it as a game tester. So next we will see few things that you should do and should not do in testing. So basically this list you can apply in any project that you work on, that might be a software or game. So let's just understand few do's. So as a tester, you should ensure that you should follow the testing strategy, as in the test plan that you have planned for the sprint or for this project. Make sure as a tester, you guys follow it from the scratch to the end. Then again, assign defect priority and the defect severity, or I can say mention the defect priority and the severity in a well-defined manner, so that it will be easy for the developers before fixing it. Then communicate the results that might be positive as well as negative, with the help of matrices to the entire team, because I believe effective communication is the key to success. Then as a tester, you should be able to learn every new technologies, new things uh, that may be introduced in the software fields on a daily basis. So that is the very important point to consider. And now let's just see few don'ts, that as a tester, what points you should not do. So never ever make assumption during testing. Like, if you guys, if you have any confusion or any ambiguity regarding understanding any requirement, then just clear it out, because assumption can be a big disaster as you move ahead in the testing phase. Then don't update test cases during their execution. Like, many of us will not agree on this sentence, but this is something which we have included with the help of our experiences, because updating test cases is something that you should be doing after executing those, not between the execution. That's the important point to take a note of it here. Then don't track defects at multiple places. Like, if you guys are using any test management tool or any project management tool like the Jira, or it might happen that in any other companies, you guys might be using the spreadsheet or Excel sheet. So don't track the defects at multiple places. Make sure that you have consolidated all of the defects at one place, and you just keep track at that place only. Also, don't neglect any defect. Like, if you think that, okay, this is something very minor issue, so to just don't neglect it. Report all the defects and in a well documentation format, and don't focus on testing the non-critical areas, because many a times it happens that in the agile world, as testing is itself a bit complex process, so it might takes it is a might type time consuming thing. So just don't focus on the non critical areas. Just make priorities where you will keep focus on the critical areas first, and then followed by the non critical ones. Now we will see the skill set required for a game tester. See, apart from the skills mentioned here, there are few skills which are common in both software and the game. Like, person should have good analytical skills, should have good visionary skills, should have ability to think out of the box, etc. However, as the game testing adds a bit more complexity in overall testing equation, so it's pretty obvious that there are few skills which are uniquely required to be a good game tester, right? So these are the skills that you should have as a game tester. Like, a person should have ability to decide or to maintain the fun factor, because the games are designed, or they are engineered with only one intention, that is to give the fun to the end user. So as a game tester, we should have the ability to decide that factor. Then we should have the ability to decide the adequate balance of difficulty between the levels. Like, it should not happen that while developing a game, your any particular game level should not be too easy, or should not be too difficult to pass on. So we should have this adequate balance, and as a tester, it's our responsibility to judge those parameters. Then we should have the ability to devote long hours to continuous gameplay to gain insight into the target audience, because there are multiple types of game testing where as a game tester you need to work for some extra hours apart from your working hours. Also, you should have the ability to test each level for bugs, which is pretty straightforward. And you should as a game tester, you should be a pro player. Means pro player as in you should have the ability to pass any level in the game, because if you don't have the ability to pass the game, so I mean, how you are supposed to test the game, right? So that was important here. Then the next we have the boxes, or we can say the approaches in the game testing. So the basically three boxes are here: blank box, gray box, and white box. It is exactly similar to what we have in the software testing. So in the black box testing, what is the core concept of it? So in the black box, we don't have the internal knowledge about the code and the underlying architecture. So what is concerned here in the black box testing is just provide the input and verifies the output whether it is as per the expected or not. So that's the only thing we do in the black box testing. Compared to white box testing, we have a full understanding on the code and the software architecture as well, where we can integrate our test cases through the CI/CD or Jenkins pipeline, so that we will test the builds that are going to uh, deploy to the testing site. And in the gray box testing, we have some mix-up, like we do have the partial knowledge about the code and the underlying architecture, but not in depth. We just know the basics things, and we can just test the things from here onwards. So the next we have different levels in the game testing. So game testing is also a systematic process, just like software testing, where testing is performed at the different levels, and each level has a different meaning of testing. It begins with the unit testing, where individual piece of level is tested, and then in integration, we check for the interface between the different levels involved in the game, whether they are working fine or not. And somewhere somehow we begin the component interface testing here, in which we keep our focus on the interface between different components of a game. The testing at higher level comes into the picture, where we perform system regression, acceptance, etc., followed by the UI UX or LAD test, which is the highest level of testing in a game. So the next point of today's session is test techniques. Whenever you are asked to test any software or a game, that may be an application or any website, so there are various techniques available to test it. In order to understand this, we should get answers to these questions, and only then any one of us can start testing. So the very first question is, how are you testing, or how we can test? So we have multiple test techniques here. We will begin with the activity-based techniques, in which we should focus on our activity or event, or simply our way of interaction with the system. This includes the scripted testing. That means our actions are scripted in the form of test steps. Then we have the exploratory testing, in which we will explore the game by our own without any script, along with the smoke and regression testing. Then we have a problem-based testing techniques, where we keep manipulating inputs, data, constraints, and analyze the results or outputs. Next, we have people-based techniques, in which we put ourselves in the different users' shoes, where we will act as an end user, having no technical knowledge about the game, or we will act as a technical user with limited or in detail knowledge about the technologies involved in that game, followed by the pair testing, big bash, expert testing, etc. And the finally, we have coverage-based techniques, in which we can include the boundary testing, equivalence partitioning, etc. Assuming that we all know this. Um, Now we have tested the game, but how to evaluate its result, right? So this brings me to our next question, that is how to determine if the test is pass or fail. So here we will simply follow evaluation test techniques and write our results, whether it is a pass or fail, by comparing our actual result with the expected result. That is pretty obvious. So from here onwards, we will see the pointers in the software versus in the game testing. So as you can see in this diagram, which reminds us the set, subset terms from the mathematics we all might have learned, right? So If you want to guess our few pointers, it is clearly visible that the blue circle, which is the software testing, is one set, and the game testing, which is in the yellow circle, that is the another set. So these two sets combinedly have some similarities as well as two differences, right? So that is what we are going to see in the upcoming slides. So which brings me to our next topic, that is differences between the software and the game testing. So we have just tried to highlight the differences here in the software testing and the game testing, both technical as well as non-technical. So the major difference I would say is in the software testing, uh, the focus is on the real world and the real data, where any problem gets solved with the help of that software. Whereas in the game, the main focus is on the imaginary and the hypothetical data or the events, because the sole intention of to develop a game is to give fun to the end user. Then the next point we have is the person, that is software tester, that makes greater use of the automation script, and they are technically advanced. Whereas in the game tester demands more concentration, dedication, and attention to detail about the feature, and they are less technically. They have less technical knowledge. In order to perform the software testing, it is required to have some professional degree or qualification, although it varies company to company, but most of the time it is required. But in the game testing, it is not mandatory to have a special degree or qualification to be a game tester. Then continuing these differences, if you talk about the automation, so in the software testing, automation will be used to a greater extent, whereas in the game testing, it does not use that much of automation. Yes, we do have use of automation in the game testing, but it's only limited purpose. Then software testing, only skilled professional can perform software testing, whereas in the game testing, any common user can perform the game testing. But the ground rule here is he or she should have the basic knowledge on games, like what exactly game is, different types of games, and then where to play this game on different devices like Nintendo, Microsoft, or many other devices. So in the software testing, we need in detail understanding about the software before we start our testing activity. Whereas in the game, it is not always mandatory to have in detail understanding about the game. So that means we can explore the game by our own and can continue our testing. Now it's time to see the similarities uh, from the software testing life cycle and the bug life cycle. So, similarities as in the different phases in the software testing life cycle. All those phases are, you know, uh, completely, or I would say, it has almost uh, complete reference in the game testing life cycle as well. Whereas the phases begin with the requirement analysis, then we move to the test planning phase where we plan our testing activity. Then we move to the next step, that is the test case development, where we start writing our test cases for a software or a game. Then we do the environment setup, like whether we need to have some automation tools. If we are planning to use some automation tools, then we do that environment stuff. Then we also decide the environments of a testing, like whether to test it on the dev, staging, or production, whatever environments you have in your project, we do the setup. Then in the test execution, we actually execute our written test cases. And then finally, we have the test closure activity. So all these phases remains the same in the software as well as in the game. Now, moving, we have a bug life cycle, or we can say defect life cycle. So it is again pretty straightforward, and it also remains the same in the software as well as in the game, where of a tester, whenever he or she finds any new defect or bug, he will mark it as a new and then assign to the developer. Once it is assigned, the developers will have multiple choices, like whether to fix it or to not fix it due to any reason that the bug reported, it might be duplicate or it is invalid. So in that case, the developer can uh, reject that particular defect, or if it is a valid one, so it will change the status to open, then fix it, then pass it to the tester to test it, then tester test it, verify, and finally the close. And so this is all about the differences and the similarities uh, in the software and the game testing. Now, uh, so here in this slide, we have the same similarities here as well, where software, like the software testing is an engineering discipline, whether it is a game application or any another type of software. Apart from this, there are other few similarities as well in the software and game, like functionality, performance, stability, compatibility are mostly the same, but the focus keep changing, like in the software and the game. And the game tester should have the same knowledge base as any software tester, but the with specific focus on what makes the game a unique. So that what stand out the game testing. Now, I would like to hand over the screen to Aditya for the next topics. Over to you, Aditya.
Yes, thank you so much. So I hope that all of you have an overview about game testing. I would like to go a little deep into the components and the most important aspects of game testing from this slide. So different types of game testing include fun factor testing, balance testing, game level world testing, AI testing, multiplayer network testing, that is also called as online testing, audio or sound testing, physics testing, realism testing, and modification in the APIs that are done by players or users or the organizations or the developers. So to give a quick overview about fun factor testing, fun factor is more of an experience the user will get while playing the particular game. It should be involving, funny, and also addictive to some extent to the user that other user type of software might not require. So this is not compulsory in software testing that it should be involving, it should be funny. But yes, fun factor testing is a very important factor in game testing. Fun factor testing requires a large number of domain knowledge, and different types of games should be played by the user who is testing, and he should also have knowledge of different genres of the game and also what makes it a fun experience. So going to the next important thing, that is balance testing. So basically balance testing is the focus is on the walkthrough of the game, how the game is to be completed from the start to finish, how the balance of the game is, how different strategies are made by the player and can overall affect the balance of the game, difficulty level of the game, and different types of player, how they interact with the games and how they make the strategies directly or indirectly to complete the game in an easy manner. So it is the developers and the testers, role that he should be given quite a bit of challenges to overcome all the levels of the game. Other things that are tested are the balancing of the weapons, the boosters, and the equipments, balancing of different levels, balancing of the difficulty levels that are present, and balancing the boss modes. So just to give a quick example here, like if you're playing a game named FIFA, which is very famous. So if you play the easy mode, then it should feel like easy. And if you go to the highest professional or the hard mode, then it should be the hardest. So basically balance testing is balancing the easy, medium, hard, and the different levels that are present in the game. Giving another example towards it, like if all of you have, I think, played the game that is Dev. So Dev is a game that is everyone is quite familiar with, and the basic requirement of it is like the level 1 should be the easiest and the level 10 should be the hardest. That is done in the balance testing. Moving to the most important and the next mandate, or we can say component, is the game level world testing. Basically, world testing is testing everything that is present around you in the game. That means each and every asset that is used in the game. It is a very big and important component. Its testing is carried out from the initial phase of the product to the very end phase of the product. It includes how number of assets are placed across the games for the number of times required. Testing one asset used all across the game would be more than 20 to 30 places. So assets are basically different types of object that are placed in the game, right from the, if we consider a game where there is an open space or where there is a closed room, so the number of assets used on the walls, actually the windows, other furniture that is basically used in the game, all the boxes, etc., need to be tested in game level or world testing. The other few important aspects, especially nowadays, all of you know that the gaming world has grown a lot and it has gone to 3D and 4D experiences. So stuck and sticky spots. So if I consider that there is an alley on a road and a player is not able to pass through it or getting stuck in that alley, so that is considered as stuck and sticky spots. Invisible walls, the walls are not visible to the user, but there is a physical wall that is present, and it is obstructing the player movements, so that is invisible walls. Map holes is something that if you are on the first floor, there is a hole that is invisible and not seen by the user, and he falls down out of the map or on the ground floor. Those are the map holes. Missing geometry or textures. So if there is a wall, to explain this more better, if there is a wall and there is a texture on the wall, but the texture is not of a good quality, and the pictures are not visible to the user correctly, that comes under texture. And missing geometry is something like if you're standing, you should standing behind a box, the user should not be able to see through the box, and all those things come under missing geometry. Positioning and LOD. LOD is basic positioning. LOD and lighting VFX is basically concentrating on the light. Like if it is a daytime, then the lighting should be bright, and if it's night, then the lighting should be light or dark. So depending on all things, these all changes are checked by the tester in game testing. So now coming to a very important thing, that is the game level and game art, level art. So in world testing, this is a very important factor. Basically, the assets dimensions and the amount of quality of the art that is present in the game is tested in level design and level art. So another very important thing, that is the AI testing. AI is basically a computer controlled opponent with artificial intelligence. How the AI reacts realistically according to the user tested, and its behavior is tracked. So there are different phases of AI that he goes in. So there is one idle state, there is an active state, there is an alert state, attack state, and guard state. So these are different types of states that AI behavior works like. So in different games, we come across different AIs. So in if I could give an example of a very famous game, that is Road Rash. So while we are playing as a single player. There are different other 14 or 13 players that are racing with us. So basically, they are computer controlled AI that are present in the game. So they play with us just like a human plays, and they mimic the behavior of a human. So few things that AI should have and must have things by the AI or the bots. They are also called as bots in a few games, like a very famous game named PUBG. So when we play PUBG, there are bots that are spawning with us in the game, who are at a very easy level, but yes, they should be present in the game and they should mimic the behavior like other players. So few things the AI should have are survival instincts, looking for covers when we are trying to shoot the bot, hunting state, not waiting for the player's reaction and proactively shooting the player or taking actions that are necessary. Then they should also involve in fight. If it is a co-op game, then they should also get into situations where they help their teammates and they also play a supporting role. So there is a different type of AI that is also called as non-playable characters. So all of you might have gone through a game named Midtown Madness. So there are pedestrians that are walking in the game that we usually like to crush or run the car through them. So those are NPCs or the non-playable characters in the game. They don't actively participate in any role, but they are necessary to give overall realistic effect to the game. So they are present in the game. AI, path findings. Path findings are basically the AI should be present if there is a game in which we have to complete the game from A point to the B point, and there are n number of rooms that we have to cross and reach the B point to win the game. So the AI should be present in the games that user is using, and not in some corner of the game or the most corner room of the path. AI or boss behaviors. So basically, boss behavior is something like if you reach the end level of the game, there is a boss, and which is a pretty difficult one to beat, and his behavior should be accordingly. Like he should have a good amount of armor. Then his attacks and weapons should be upgraded, and he should be difficult to beat. So basically, as we are going to complete the game and it is the end of the game, the boss behavior should be difficult for the player to beat. And in order to do that, the player should make a good amount of strategies and try to beat the boss. Yeah, next slide, please. Multiplayer network testing. Basically, this testing includes online testing. So how game communicates with the server online is multiplayer or network testing. So it is also called as online testing. Other testing aspects include failure in connections, dropped connections, lag, invisible players or AIs, invite and friend system, unaccepted invitations. So to explain this point shortly, online testing is like if your internet get disconnected, then how the behavior will be of the game. You are put out of the game because your internet just got disconnected. So after rejoining, in what place will you spawn in the game depends on the game. Different games react differently depending upon its difficulty and competitiveness. Like if it is a co-op game, then the spawning of the player after there is some drop of connection should be around the players that he is playing with. So these types of things are checked. The invite and friend system is also checked, whether we can invite other people, where we can accept the friend request of other people. So before entering the game, if my connection got get disconnected and I was having 15 points in the game, so after rejoining the game, I should have 15 points. So there should be no scoring errors if we are rejoining the game because of some drop in the connection, etc. Coming back to an important topic in lag, like in competing gaming, lag is a very big thing that player face. This is because of the latency issues and the engine issues that we have in the game. So there are two reasons to go behind it. So this has also been tested under online. Coming to the next topic, sound testing or audio testing. It actually in game testing, sound testing is very important as it overall determines the user experience. It is very complex as compared to software testing, as many sounds are played simultaneously in the game at the very same time. And if it is a competitive game like CSGO, Valorant, Rainbow Six Siege, Rainbow Six Extraction, such games that are very complex and involve a large amount of sound and music and SFX playing at the same time, then it is very important aspect because it determines the quality of the game at the end of the day. Many things can go wrong, like audio drop. You must all be knowing audio drop. Like we face it during our meetings as well in the different software that we use. So it is similar over here. Skipping. So skipping is basically like some amount of chat or that you're doing with your co-op partner or someone. So you're missing on that. Distortion, like there is a noise in the communication or the sound that is played. Missing sound effect on actions performed. Like if you're loading a gun or you're driving a car, you should have the particular different sound. If you're using different cars, then you should have different sound effect for that. If you're reloading a gun, then it should have a different sound. If you're reloading a pistol, then it should make a different sound. So there should be different sound effects for the actions that are performed. If a person is walking, if a person is running, both sounds should vary. Those are covered under missing sound effect on actions performed. Volume levels, like increase and decrease of the volume. This has been tested in volume levels. SFX and sound propagation. This is a very important and it is a very fun testing that you can carry out. So if there are 4 rooms in a row and you are throwing a grenade in the room that is next to you, so it should sound like that. And if you are throwing a grenade in the very far room, it should sound like the sound is coming from a very far away room. So this is basically sound propagation and SFX. Physics testing. It is basically how the engine perform and how the performance of the engine affects the gameplay. Different games are, different games that are heavy or that are light. So nowadays 3D games and competitive games are very heavy on the engines. Or it also depends how which type of experience a user is getting. So because if physics testing is not done properly, then it can totally break the geometry of the game. So basically the engine is stressed with many players and the dynamic loading is checked on it. Physics bugs are very difficult to spot and reproduce. So it requires a knowledge and the different domain knowledge is required. Different types of games you should have played in order to do physics testing. So it is a bit of complicated testing part in the game testing which is carried out. Realism testing. This is like how the realistic experience is given by the game to the user. If a user is driving a car, then it should actually feel like a user is driving an actual car. If a user is using weapon like AK-47 or a Maverick gun, then he should have the experience that he is using that type of gun. And then the reload and all those actions that is carried out should also feel realistic to the game and to the real world. If he's flying an aeroplane, then it should feel like he's driving an aeroplane, and it should give a realistic experience to the user, or it should give a close experience to the emulator type of experience at least. So different type of mods are used in the game, require different approaches. Competitive games add dimension of not allowing mods user to gain unwanted advantage so that they can exploit the game. So different modifications are done by the users or the players or the testers in order to make the modifications in API that change the approach of the game. This is mainly done in the competitive gaming. Imagine, and also like, open APIs are common in software, but in competitive games, it adds a different level of dimension and difficulty. And it can be easily used as an exploit for the gaming by using their mods. Next slide. Tools used in game testing. So now that we have finished with all the important components, I have jumped to the tools that are basically used by the game testers. So test trail. This tool is used to manage, track, and organize test cases. Game bench, performance tracking tool to measure frame rates. So the drop in the frame rates and the FPS is tracked through game bench. Charles proxy, web debugging tool used to monitor the network calls, decryption, and the web traffic that is present on the server. So it is basically to monitor the server and the traffic that is present on the server that will affect the game. XRA for Jira. This is a test management tracking addition Atlassian the add-on that is present for Jira, and it is used uh, widely in while game testing. Telescope, used to share and uploads reports to the management level and the developers and the producers of the game, and it is basically used to share it in a report format. Sandbox, it is used for the isolation of the test environments. So test environments are also called as different floors. Like in software testing, it is staging, production. So like there are floor 1, floor 2, floor 3 that is done by the sandbox in game testing. Tableau, it is used to get the live visual data from the server in a report format. It is usually a graphical representation or a visual kind of representation of the report of the scoring system, the progression of the game, or you can say the data that is present on the server about the players that are playing the game in co-op. We can get all that data from in the report format. So coming to the final thing, conclusion, software testing in general and game testing in particular are extremely complex activity. It takes a lot of time and effort and patience to carry out both types of testings. Of course, it requires experience and knowledge. In the game testing, the technical knowledge is not required, but one thing that is required is experience of playing different types of game and how the game is played and how you can be best at it. It needs to be handled very delicately so that we don't produce a waste product. It is necessary if you want to release a game or a software, it should be valuable to the user and he should get an overall good experience and the quality of the product should be at its highest.